Hi guys, Audrey here. So this time we're going to do a differential equation that has two special things going on. The first is that it has a trig function, and I know how much you all love trig functions. So this one has tangent x, plus we have an initial condition, so we're going to actually have to evaluate trig functions somewhere. This is 0 is less than x is less than pi over 2. We'll talk about it a little bit more towards the end. It's really honestly not that important. It's just a small thing we have to think about. Okay, so let's get started. First, we want to solve our differential equation. So step 1, we rewrite y prime as dy dx. So dy dx tangent x is equal to 2 plus y. Step 2, we separate our variables. And a great way to start separating variables, that dy dx is alone on the side without a plus or minus. It's just being multiplied by things. So I'm going to immediately multiply that dx over. So I have a clear dy side and a clear dx side. So I have dy tangent x is equal to 2 plus y dx. Now, the tangent x we can see is on the y side, and the 2 plus y is on the x side. So we can use multiplication or division to move them from side to side. So we're going to divide both sides by tangent x and both sides by 2 plus y. So we'll have 1 over 2 plus y dy is equal to 1 over tangent x dx. And notice how I've written it with the dy at the end of the y side and the dx at the end of the x side. Remember how we have talked about the fact that dy or dx is kind of like a period at the end of your integral sentence. Periods go at the end of sentences. So I want to make sure that when I'm gotten to the point where I'm about to integrate, they're at the end. So they're the last thing I write on each side. So next step is to actually integrate both sides. So I have the integral of 1 over 2 plus y dy is equal to the integral of 1 over tangent x dx. Before I integrate, I'm just going to look at that 1 over tangent x. I know the integral of tangent x, but that doesn't matter because it's in the denominator. I don't have tangent x. I have 1 over tangent x. So I'm going to need to use my reciprocal identity here to rewrite this as cotangent. So before I even think about integration, that's the first thing I'm doing. So 1 over 2 plus y dy is equal to cotangent x dx. Now, both of these are known forms. You should be able to look at them and just write down the answer. We have ln of 2 plus y is equal to natural log of sine x plus a constant. So here, we just remembered our reciprocal identity that tangent x is equal to 1 over cotangent x, which is equivalent to saying that cotangent x is equal to 1 over tangent x. And then these were both just known forms. The one on the left there is the integral of 1 over ax plus b dx is equal to 1 over a natural log of the absolute value of ax plus b plus c. Okay, so now let's go back and look at our step 2. In step 2, we did 1 over 2 plus y. So when we did that 1 over 2 plus y, we had to make the assumption that y was not equal to -2. Because if y equals -2, then we're dividing by 0, and that's not okay. So because of that, we're going to have to do this one little thing in our next step when we are simplifying. And regardless of whether or not we divide it by something, this is usually a good thing to do because it's going to make our problem easier to solve. So we know in order to get rid of a ln, we can do e to the power of both sides. So I'm going to get 2 plus y is equal to e to the natural log of sine x plus c. Now the thing that we're about to do to deal with the fact that we divided by y plus 2 is that plus c right here gets moved to the front. So I have 2 plus y is equal to c e to the ln of sine x. Now if you don't remember why we can do that, we're basically saying e to the a plus b is equal to e to the a times e to the b. So e to the ln of sine x plus c is equal to e to the ln of sine x times e to the c. But that e to the c right there is just a constant. So I'm replacing it with c. Or I'm letting c also have the possibility of being 0. So basically we're saying c is equal to e to the c or 0. And if c equals 0, then that brings that back, that possibility that y equals -2. In any case, what's important is that you do this thing. You just need to make sure that that plus c up top becomes a c multiplied out front. Okay, all right. So now we have, I'm just going to go down a little bit. Now what we have is, we're still on step 4. We have 2 plus y is equal to c e to the ln of sine x. But e and ln cancel each other out. So in this, for the same reason that we took e of both sides to have that 2 plus y come out of the ln, e to the ln of sine x is just sine x. Now, remember that we can plug in our initial condition wherever we want. So I'm going to plug it in here. So my initial condition was that y of pi over 3 is equal to 2. So this is saying y equals 2 when x is equal to pi over 3. So down here, we end up with 2 plus 2 is equal to c sine of pi over 3. So 4 is equal to c times 2, I'm sorry, what am I saying? Times root 3 over 2. Now that root 3 over 2, you should have somewhere in your notes or the unit circle in your head, something, you have a place where you have it written down, all of the values that sine takes on between 0 and pi. So this right here is one that your calculator won't tell you. It will give you a decimal. And remember, we do not like decimals. So this is one that you're just going to have to memorize, that sine of pi over 3 is equal to root 3 over 2, giving us that c is equal to a over root 3. Now, in the beginning, we said that we were really only thinking about what's happening between 0 and pi over 2 for my x values. So really, we're saying, I know that sine repeats itself over and over and over again. We don't want to think about that repetition. We only want to think about what's happening between 0 and pi over 2. So we really actually have nothing to do with that. It never shows up as something that's important for us. It's just we have to kind of think about, we're only looking at what's happening for x values between 0 and pi over 2. So we got our c as 8 over root 3. Our final answer here is 2 plus y is equal to 8 over root 3 sine x, which implies that y is equal to 8 over root 3 sine x minus 2 for our final answer. Now just note that had you not done this thing right here, where we brought that c down front, this would have been a whole lot more challenging to simplify. Bringing the c down allowed us to super easily solve for c when we got to this place right here. It was not in an exponent, it was down out front, made it super easy to solve for. So that's another reason that it's super important that you bring that c down to the front. All right, that's it. I hope this made sense. Bye, guys.